Uh, in this video, we're going to look at the calculation of evolving relative velocity. Now we are having a scenario where we have two planes. One is moving due north, one is moving. If this is the point of origin, there is a plane moving in the north and it's plane A, so it is moving with velocity v. Now if we take this to be the horizontal, they are saying that there is another plane that is moving in the northeast direction at 30 degrees. Now, when we are drawing this diagram that will give us a triangle velocities, we must make sure that the velocities are proportional. The lines are proportional to the velocities. Now, this, if we can go back to our question, VA is 40 kilometers per hour and VB is 30 kilometers per hour. So what does this one mean? If we can close them to give a triangle of forces, and then after drawing the triangle of forces, the next thing is knowing which one is the observer. They say we find the velocity of A relative to B, so the observer is in plane B. So now let's use the geometrical method. We use the geometrical method. So I've said geometrically. Now geometrically, for us to be in position to find VAB, we use the cosine rule. So we shall say, using the cosine rule. Now if we use the cosine rule, we know that VAB squared is equal to VA squared plus VB squared minus 2VA VB cos this angle 30. Therefore, our VB, substitute this is 40 squared plus 30 squared minus 2 times 40 squared times 30 cos 30. So let's get a calculator and we try plugging in these values. 40 squared plus 30 squared is equal to minus 2 times 40 times 30 cos 30 is equal to this value. So root of the answer gives us our velocity VB as 20.53 kilometers per hour. That's what it has given us as the relative velocity. But remember, velocity is a vector quantity whose magnitude and direction must be specified. Now let's look at getting the direction. Now to get the direction, we use the sine rule. To get the direction, we use what? We use the sine rule. So how does the sine rule work in this case? The only unknown is the angle at which this resultant velocity is being observed by the observer in aeroplane A. Therefore, we are going to say that since VAB is known and it is VB is known, but it is the angle that is not known, then VB out of sine theta is equal to VAB out of sine 30. Therefore, sine 30 is equal to VB sine 30. What is out of VAB? So we substitute. VAB was 30, sine 30 out of 20.53. So 30 sine 30, 15 divided by 20.53, we get the sine inverse of the answer, and we realize that theta is equal to 46.8 degrees. We conclude and say that therefore the relative velocity, I mean the velocity of A relative to B is 20.53 kilometers per hour at 46.8 degrees above the horizontal. Now this has been using the geometrical method. Now let us try a vector calculus. So using vector method, we also look and see if it is true the vector method also brings the same. Now for the vector method, one, we must be knowing the directions. Plane A is moving at this direction, then plane B is moving at that direction and at 30 degrees. Now the velocity, the relative velocity, or the velocity of A relative to B is velocity of A minus velocity of B. So now vector-wise, the velocity of A in the horizontal direction has no component, and then the velocity of A is 40 in the vertical direction minus sine 30 into 30 cos 30. Now this is 0 minus 15, we get 15 cos sine 30 is a half. That one we should be knowing that sine 30 is a half. So 30 times half, we get 15. So 0 minus 15, we get a negative 15. Then 40 minus 30 cos 30 gives me 14.02. Now, for us to be in position to get the resultant velocity, we are supposed to get the magnitude of those velocities. So this is negative 15 squared into 14.02 squared. Therefore, 15 squared plus 14.02 squared root of the answer. So we also realize that again from here this is 25.3 degrees C. Now, when we are using vector calculus, we get our angle from tan, and we know that tan is always the horizontal over the hypotenuse. So this is 14 point that divided by 15, and we get the value of theta. So 14.02 divided by 15 is that value, the tan inverse of that answer. We are getting now, here we get 43.07 degrees, and we conclude and say that still the velocity of A relative to B is 20.53 0.5 kilometers per hour. Okay, now when you look at the relative, when we draw a diagram here that looks like this, in which direction is this? This is in the northeast. Northeast. So we shall have calculated and we have finished. So that is how you should go about that question.